extensible, you can stretch it, but it's elastic, right? And the more you stretch something, as long as you don't overstretch it, right? The more you stretch something, because it's elastic, it will recoil back to its original shape. And when it recoils, does it recoil, the more you stretch it, does it recoil with a greater or a weaker force? Greater force. So this is going to show us an increase in, we'll just call it elastic recoil. Does that make sense? Yeah? Just snaps back faster. Now, we didn't do anything except put more blood in the heart. So all of this is an intrinsic property of the structure of cardiac muscle tissue. It's elastic, right? Because it can stretch and it's elastic, you put more blood in it, it's going to stretch more, it's going to recoil more. Is that okay? That make sense? All right. So you leave me there. Also, if you were to, what's preventing myosin from binding to actin? Tropomyosin, right? And if I were to take a sarcomere and pull it like this, I'm stretching it, right? What am I going to be doing to the tropomyosin also? It's going to be stretching. Does that make sense? And as you stretch tropomyosin, do you think it might move a little bit? Yeah. And if tropomyosin, now again, we don't have calcium, it's not calcium or anything like that, right? We're stretching it, we've moved tropomyosin, guess what's going to form? Cross bridges. So because of this stretch, we're going to get an increase in cross bridges. Now I'm calling these passive to imply that this is independent of calcium. This is not calcium dependent cross bridges. This is just due to stretching. By the way, this right here, this phenomenon of an increase in cross bridges is something called the Frank-Starling principle. And it goes kind of like this, right? Tension and length. As you increase the length of a sarcomere, the tension goes up to a point. And then what happens if you were to keep stretching it, you're going to break it, right? You're going to reduce the ability of actin and myosin to overlap. So there is some maximal length that will give you the maximum tension, and that's due to this kind of arrangement of cross bridges here. So because of this, so this is that Frank-Starling kind of principle right there. Because of that, if we get more blood coming back to the heart here, we're going to stretch and get recoil. We're also going to form more cross bridges. When this gets the signal to contract, that's the excitation-contraction coupling. When that happens, tell me what happens to the force of contraction. Greater or less, or the same? Greater. Makes sense, right? More elastic recoil, more cross bridges, means more force. That makes sense. Now again, we didn't do anything except stretch it, right? This is all intrinsic. Preload is all intrinsic. By that I mean we're not adding epinephrine, we're not putting hormones on there, we're not doing anything to tell us to contract harder. We're just putting more blood in there. And because of the structure of muscle tissue, we get an increase in recoil and an increase in cross bridges. So when you get, so you had an increase in venous return, which triggered an increase in the end diastolic volume, which gave you a greater force of contraction. What happens to the end systolic volume as a result of that? Up, down, stay the same. The heartbeat, the contractile force of the heart was greater, right? More blood left in the ventricles or less blood left in the ventricles? Less blood left in the ventricles. This is the blood left in the ventricles. Does this go up or down? Down. Okay. All right, you with me on that one? Yeah. So, end diastolic volume went up here, something greater than 135. And systolic volume went down, something less than 65. Tell me what happened to stroke volume. It went way up. And if stroke volume goes up, what happens to your cardiac output? It goes up. Okay. So just by moving more, because of these reasons I just told you here, the structure of cardiac muscle tissue, you get more blood flowing. Cardiac output increases. It's what we call an intrinsic property of the heart. Intrinsic property of the heart. Is everybody okay with that?